So that happens under functional control. So now let's make this a hard nut. You say, now, I know you're going to use this temper out. I want you to really bite into this thing. You say, okay, now go ahead and bite that nut. You can't. You'll bite as hard, quote, as hard as you can. It cannot happen. You'll get about to 30% of your maximum ability, but for some goofy reason, you can't incise through something hard like that. So what do you do? If you really needed to bite through it, what would you do? It's not a very far, yeah, you'd move it to here. It's not a very far distance. You really aren't gaining a whole lot of leverage by moving it just that far. What you're really doing is completing a different type of circuit. You're now allowing more electricity to be funneled to that temper house and more fibers can light up. As soon as you complete the circuit here, man, you've got all kinds. It's not the distance that makes that thing more powerful. It's not powerful, it's more electricity to the engine. You've completed the circuit that allows the electricity to get there. And man, a bunch of fibers just take off. If you put the marshmallow back there and bit with if you could recruit that many fibers, and you could, when you complete that circuit, the velocity is incredible. There's no resistance there. So when you want someone to elevate through the air, and you could somehow say, I want you to close as hard as you can and put something in there, they do it. If you can remove, bam, those teeth just slam together. So if someone is closing with a lot of velocity and then barely touches their teeth, their lateral pterygoids have kicked in. It's sort of like the air brake, and it slows them down. So they don't; those openers will fire up during intense closure to temper it. Otherwise, your teeth slam together. This is an idiot, right? You said muscles are stupid. When this thing cranks up, it's going to go. This thing is flying through the air if there's no resistance.
Jim, is this the PDL innervation that has a big influence, or?
The PDL is the conduit that completes the circuit. That's how there's the pressure sensations there. And it's where we're going to get into weirdness is voluntary. You ask someone to do something and what actually happens when they're chewing on different resistances. You know, if someone's biting on something really hard, their rate of closure stays the same. But the bolus is getting softer and softer, and so the elevation intensity is decreasing. Someone is sensing the resistance. It's the PDLs. You can ask someone to clench, and that's a whole new phenomenon. It's really kind of fascinating to watch it go. But it really is true. You've seen it, and boom, and it gets really hot. So here's someone with air. They're in a rest position. You want to measure it, you'll get 0.2 microvolts maybe. They're just sitting there. There's a whole bunch of circuits that now can be completed, and the degree of circuitry completion will dictate how many muscle fibers will be contracting. If you complete the circuit of the anterior teeth, you'll achieve a 30% circuitry completion. So you get 30% of maximum clenching intensity when you only have anterior contact. If you get canines in contact, that circuit will jump you up to about 75 to 80% of maximum. If your molars are touching, you'll get maximum clenching intensity. So to say that molars contact causes intense clenching or causes maximum, it allows for. It doesn't cause it, it allows for it. So we go back to parafunctional control. The number one, the first thing you're trying to do is minimize muscle contraction intensity. And the way you do that is you don't provide the circuitry necessary to obtain intense contraction. You minimize muscle contraction intensity by minimizing the circuitry necessary with incisal edge contact through its long axis. So the first thing you think about in parafunctional control, we're not talking chewing food anymore. We're not hanging out during the day anymore, clenching teeth during the day. This is at nighttime. We have to minimize muscle contraction intensity, and the elevation is going to happen. We need to minimize the intensity, and you only allow for minimal circuitry completion. So this jaw clenching, these muscle elevators, the jaw elevators, the intensity is determined by the type of the teeth that are in contact and the degree of resistance provided. A tooth and the opposing jaw is considerable resistance in clenching. So now, what's in between the teeth is the conduit. You either have to have something in there, like a splint, or a tooth-to-tooth contact. Whatever's there allows that circuit to be completed. So now you're watching this motor nerve light up and turn off and light up and turn off, and you're watching it. It's not that bright, and you see that there's the degree of voltage flow, we'll call it, the frequency of activity, and how long it's lighting up in each cycle. And if you knew the numbers, you'd say, I'll tell you, I know what's going on right now. That person's chewing a marshmallow. So this mesencephalic nucleus is the regulator of off to on to off to on to off. It allows that cycle to happen. The degree of resistance here and the position of the bolus is dictating how much electricity is flowing out of that motor root. If you could just watch it there, you'd know what would be happening out here. What's happening doesn't dictate this. This creates that. So if you watch it, all of a sudden, it changes a little bit, and it gets a little brighter. There's a lot more intensity of electrical flow, but the rate and the frequency is the same. It's because the resistance is greater. Something with a high degree of intensity is happening right now. Now they're chewing on something really, really hard. Now, if all of a sudden the duration and rate was kind of goofy, you'd say, "What? That person has a chewing dysfunction." You're watching them chew food, you start to see things. When you chew, your jaw is moving off to the side, and it shouldn't have to be doing. You're closing awfully fast. You don't need to do that. You're going to watch velocity traces tomorrow. How come this person slows down at the very or goes too fast? What's going on here? Either the structures are messed up, or there's been pathophysiology at a prior time that's modifying the chair side presentation, which I call the dysfunction. There's nocturnal parafunction, which gives you chair side dysfunction that you look at. So here's a dysfunctional way of chewing a marshmallow. It's not how you're supposed to do it. So there's one more thing that dictates, that it influences this functional masticatory activity, and it's where the mandible happens to be orientated during the event while the mandible's elevating. And the position of the bolus and the position of the mandible are consistent with each other.